Hey people! Last time we learned all about decoders. This time we're going to be looking at encoders. Find out everything you ever wanted to know about these fascinating devices right after the intro! Alright folks, if you've been paying attention to these videos, then you already know what a decoder is. The opposite of a decoder is an encoder. An encoder encodes binary signals, that is, data. And as with decoders, the signals can be in analog or digital form. Encoders are able to take things like data packets and encode, package, and even compress them. Together, the two devices form a logic unit working opposite one another. Write this down. An encoder is the opposite of a decoder. It is also capable of converting signals in analog or digital form. So what does one of these badass encoder devices look like? Well, we've already learned that an encoder is the opposite of a decoder. Because of this, the number of inputs and the number of outputs is exactly the other way around. So, with an encoder, the number of inputs we have is 2 to the nth power, which means we've got n outputs. If we have a 4 to 2 encoder, it's gonna have 2 squared, that is, 4 inputs and 2 outputs. With the inputs, there's always exactly one with a value of 1 or true. The 2 outputs are always in the form of a binary number with n digits. So, in our case, a 2-digit binary number. The whole thing is basically a mirror image of a decoder. Like a decoder, an encoder may also feature a larger number of inputs and outputs. An 8 to 3 encoder would look like this. Once again, each input features a single 1. And now the 3 outputs form a 3-digit binary number. So what we need to remember is that an encoder always has 2 to the nth power inputs and n outputs. So it's essentially just the opposite of an encoder. The whole thing can also be described as a function. Let's take out 0 for example. We're going to look in the table and write down every line that has a 1 for out 1. From the top, that's not I0, I1, not I2, not I3, and so on. At the end, we've got 4 blocks, each connected by an OR symbol. Since for each one of these combinations, we get a 1 for out 0. But since we don't want to get carpal tunnel writing this out, we can take all that and write it like this. This way, we can just leave out all the not ones. This means that out 0 is always true when one of these 4 inputs are true. And since we only have 1 1 for each input, we can easily express the whole thing like this. Out 1 and out 2 would then look like this. So to get all this out of the table, we just need to see where there's a 1 under the out. In that line, we then find the input that also has a value of 1. Then, each input is connected using the OR sign. At the end, we've got 4 inputs, each of which produce a true value for that output. Pretty easy, ain't it? Man, that is pretty easy. Now we can also set up our encoder as a circuit. Let's go ahead and use our 4 to 2 encoder for this. This one always has 2 inputs that yield a true output. So out 0 could be represented by the function I1 or I3, and out 1 would be I2 or I3. As a circuit, it's gonna look like this. Out 0 gets I1 and I3 as inputs, so we just slap the symbol for an OR gate in there. It's the one that looks like a spaceship. Out 1 gets the signals from I2 and I3. As for I0, we don't have any use for it in this encoder. Encoders tend to be used in combination with decoders. They're the team rocket of encoding and decoding both analog and digital signals. Together, they form a logic unit, but they always work opposite one another. So yeah, pretty much exactly like Team Rocket, come to think about it. Alright, so if I wanted to teach my Pokemon about encoders, what can I say? Like a decoder, an encoder is a device that is capable of converting either analog or digital signals. Encoders are able to take things like data packages and encode, package, and even compress the signals. An encoder always has 2 to the nth power inputs and n outputs. In an encoder, one of the inputs always has a value of 1. The outputs always form an n-digit binary number. If you want to set it as a function, you just have to see which inputs lead to a true output and connect them using the symbol for OR. From there, it's easy to create a circuit using gates. Together, a decoder and an encoder form a logic unit, but they always work opposite one another, encoding and decoding data. Alright guys, once again we've come to the end of our video. If you want to see more cool stuff and print out the summaries, just head on over to simpleclub.de. See you soon. Adios amigos!